Okay. Well, it is 11 a.m. and we will go ahead and get started with our second to last Weather Buddy Wednesday webinar. This week's topic is going to be on the water cycle. And I just want to give a quick shout out. I spoke to someone with the Master Naturalist yesterday. If you're with any of the Master Naturalist groups, just want to welcome y'all to our webinar this week. We really appreciate y'all being here today. But we will go ahead and get started. These webinars are really designed for students within the 3rd to 8th grade science class range, but I think anyone can learn something from these webinars. And if you have any questions as we go through this topic, again, there is a chat bubble at the top of your window. Go ahead and click that, and if anything pops into your head when you're watching it, or if you want me to explain on something a little bit more, just go ahead and ask that question, and then I'll also take some questions at the end. So we can just make this as interactive as possible so that you get the most out of this. So with that being said, we will go ahead and get started in talking about the water cycle. So one of the most important things to think about with the water cycle is actually where is Earth's water. So water can be found all over the Earth. And if you're watching at home, maybe you've got your kids with you or someone else at home that you're watching this with, I want y'all to talk about where you think water is actually located on the Earth. There's probably some really common places that you think about, like the oceans, lakes, rivers, and streams. But then there's also probably some places that you may not be thinking about, like ice caps and glaciers, or even in the atmosphere. Now, clouds are probably the biggest indicator that there is water in the atmosphere, but there's actually water in the atmosphere that you don't see. And that's pretty interesting. So if it surprised you to learn that water is found in the air around us, that's basically what the atmosphere is a fancy word for, the air around us. Water can actually be found in 3 different forms. So the one that you probably think of when you hear water is liquid water. But it can also be a solid. So the ice cubes in your freezer, it's solid water. And if you've ever made pasta or tea, anything where you've had to boil water, the steam that comes off of that is actually known as water vapor. So there's 3 different forms of matter that water exists in, and that's the liquid phase. Again, that glass of water. You can also have water in that solid form as an ice cube, and then the gaseous state or the gas state of water, steam or water vapor, that is the 3rd form. So water never actually leaves the Earth, and it's constantly going through these different form or phase changes as it moves through the atmosphere, the ocean, our waterways, and across the land. And these changes are actually what we know of as the water cycle. So what actually gets water traveling through this water cycle? There's actually 2 very interesting properties that actually affect this. And they're both things that you've actually seen in everyday life, which is pretty exciting. So heat from the sun is one of the biggest drivers for the water cycle. But then there's also something known as gravity. And gravity, in its most simple form, is an invisible force that attracts objects to one another. So gravity actually is also a very big travel agent for water as it moves through this water cycle. So what starts off the water cycle? Our first step as we move through these different phase changes is evaporation. And evaporation is what happens when the sun, remember that first travel agent we talked about, is when the sun heats liquid water. Now, what this actually does is it causes that liquid water to turn into water vapor, that gas state of water. And this is how water gets into the Earth's atmosphere. Now, the image that I have on the right here is actually an image of the Aral Sea. And the black outline that you see in this image here is the original size of what the Aral Sea was back in the 60s. And what actually ended up happening is water stopped flowing into the Aral Sea. So basically, the Aral Sea began to evaporate. And so this satellite image here shows the sea sinking as liquid water changes into water vapor, or that gas form of water. So we can actually see this evaporation process happening. Now, this is a much longer time than what we would expect to actually watch a process happen over. You're not going to just sit and watch a sea for several years. But this does a really good job of showing how evaporation can actually change that liquid to a gas. Now, I have a few fun facts interspersed through this presentation, and one of the things that I think is important to point out about the water cycle is that water can actually evaporate from plants. So I actually spent some time living in Nebraska, and this is actually the first time that I really got to experience this concept. But water evaporating from plants is called transpiration, and grassy areas or fields with corn or soybeans, anything that has a lot of vegetation, a lot of plant life, actually produces a lot of water vapor. So this is a lot of times why we see grassy areas experiencing fog before areas covered by concrete, because of all of that water vapor that's sitting just right above that field or plain open spot of land. Now, we're going to jump to our next step in the water cycle, which is condensation. So clouds are one of the most common examples that we see as a form of condensation. And as water vapor rises up above the ground, it cools and turns back into liquid water. And so that's what these clouds are here that we see in this image, is condensed liquid water. So if enough of this water vapor cools, this is where we get those cloudy days. So if you've ever gone outside and wondered, why don't we have any clouds today? It's probably because there's not enough water in the atmosphere for those clouds to form. Now, the third step is precipitation. So when a cloud is full of that liquid water, a third step happens, and that's basically rain. So when that water that's in the cloud becomes so heavy that the cloud can't hold it anymore, it falls. And this is where gravity really comes into our water cycle process, is that's what helps that rain fall back to the ground. So our fourth and final step of the water cycle is known as collection. So when water reaches the ground, it either soaks in or flows into lakes, rivers, or the ocean, and this process is known as collection. So if water doesn't soak into the ground, that's known as runoff. Meteorologists aren't really creative, so it's a pretty self-explanatory term, right? So if it can't soak into the ground and it moves into your waterways, then it runs off into your waterways. Now, soil actually acts like a wet sponge, so there does become a point where the ground becomes too wet and it won't allow water to soak into it. And so this is what causes flooding. Now, this is a view of the Nueces River just north of Corpus Christi in November 2018, and this is some of the river flooding that was going on along the Nueces. So we can actually see on satellite some of the impacts of the water cycle, and it's really, in this view, water moving outside of that main channel that the Nueces River moves through, and flooding nearby lands. So to put this all together, we basically have sunlight that heats water. So it could be the ocean, it could be a lake, a river, and then some of that water actually begins to evaporate. And as it evaporates, this changes liquid water into the gas form of water, which we call water vapor. And eventually enough of that water vapor is put into the atmosphere, it cools enough, and then it condenses into what we know as clouds. Now, we keep adding more and more water to these clouds, and eventually it just becomes so heavy that it doesn't stay within the cloud anymore, and gravity takes over. And then gravity helps that water fall back down to the earth. And eventually that water will either collect in a lake or a river, or it'll run off to a larger body of water, or it'll actually end up soaking into the ground. So we've got those 4 steps that all work together to help move water through different parts of the atmosphere, oceans, and across our land. So that's pretty interesting. And we'll talk in a few slides about why that's so important. But one of the things that I think is really interesting, and it's actually an experiment that you can do at home, is basically if you've ever made ice. So if you don't have an automatic ice maker, get a cube, get a tray of ice and put some water in it. And then leave it in your fridge and check on it every few days. So check on it once it's frozen, and then check on it a few days later. One of the things that you'll probably notice as you're checking your ice cube tray is that your ice cubes actually get smaller, even though no one's touched them, no one's done anything to them. This is actually the result of a process called sublimation. And this is what happens when solid water goes directly into that gas phase, so that there is actually water vapor in your freezer when this happens. This is also, interestingly enough, the reason why a lot of people will save hailstones after a strong thunderstorm and put it in their freezer, and then they'll be really surprised when they go back to check on it and they find out that the hailstone is much smaller than what they originally thought it was. It's not because the hailstone was not measured correctly the first time. It's because this sublimation process, or this process where that solid water changes directly into a gas, was actually happening in their freezer. So if you're looking for a science experiment to do at home, again, that's something you can definitely try. So why do we care? Right? Why are we taking this time to learn about the water cycle? Well, the water cycle is a pretty important driver of the weather that we see, and especially the weather that we see here in South Texas. So what I have here is a radar loop of a few days in September 2018. And this is the end of a pretty wet period for South Texas. And essentially what happened is, I think over this 2-week period, parts of the area saw over 20 inches of rain. And this was kind of the final event of that. But basically, we kept putting rain into the ground. So we made it so that the sponge that our soil normally acts like was already full. And what happens when you try to pour water onto a sponge that's already soaked? Well, that water doesn't go into the sponge, it runs off of it. So that runoff that we talked about went into our rivers, our lakes, and even actually caused flooding in roads. There were quite a few impacts from it. So I have some pictures of some of the flooding that happened in the region in September 2018 from that event. But we can see when the water cycle is really active and we go into a really wet time of year, or we see a lot of that precipitation, a lot of that third step of the water cycle, this is when we tend to get a lot of our flooding impacts, especially here in South Texas. So lots of standing water, and that's a problem because that's not, not a safe thing to drive through or play in. And I have a question about what was it in September 2018 that caused this flooding. It was actually a tropical wave that moved across the Gulf of Mexico and really brought in a lot of not just tropical moisture, but helped keep regenerating these showers and thunderstorms that produced this flooding. It was actually pretty close to being called a tropical disturbance by the National Hurricane Center. So it was, a borderline tropical system. But that was the main thing that caused this flooding around South Texas. Now, on the flip side of the coin, for us here right now, this is actually the latest drought monitor. So if you have any gardening or farming interests, you're probably pretty well aware that things are dry outside. So when we go into a phase where we don't have a lot of rain falling, so again, the ground is really dry. Well, what that does is that actually has really big impacts for farmers. It can cause fire weather problems. So if we don't get enough rain, your grass dries out, and your grass can actually be pretty easy to burn when it doesn't have that moisture in it. So on the flip side of the coin, changes in how often we see that rainfall from the water cycle actually can cause really big drought problems for us here too in South Texas, like we're seeing right now. So if you want to learn more about the water cycle, because this is just a really high-level overview of it, there's actually some really good resources out there for you. The U.S. Geological Survey actually has a water science school that you can learn about all different kinds of water topics with. And then the National Weather Service has its own weather school called Jetstream, and you can learn not just about the water cycle, but thunderstorms, hurricanes, any weather topic of interest. This will actually give you many lessons that you can go through to really expand your knowledge about any topic that you're interested in. And then the final one would be NASA. They have their own water cycle page, and it may surprise you to know that NASA has this, but a lot of the satellite images that I showed in this presentation were actually obtained from NASA data. So they have a really good high-level overview of how the water cycle can be seen on a bigger picture. But again, that water cycle that we went through has those 4 steps driven by sunlight and gravity. So we first start with that evaporation. We eventually get enough of that liquid water to change into water vapor that it condenses again. So this is where this cloud comes in. We talked a little bit about transpiration from plants. So the water that plants have evaporating, and in drought conditions, again, there's less water in those plants, but enough of that condenses to form clouds. Eventually the water in those clouds becomes so heavy that it can't hold it anymore, falls out as rain, and then it either gets soaked up into the ground, runs off back into our lakes, rivers, and eventually the ocean. I want to thank y'all for being a part of this Weather Ready Wednesday. We have one more scheduled next week. I want you to take note that the time is actually at 3 p.m., so it's not 11 a.m. And if you've been hanging tough with us through these, I really appreciate everyone making it through with some of the technical difficulties we've had. Again, we are recording these. We're in the process of captioning these talks, but they will all be available on our webpage. There's a link at the top under the news headlines for you to check it out. So join us next week at 3 p.m. to talk about hurricanes. Really excited about that one. Hurricane season is just around the corner, June 1st to November 30th. But today's talk over the water cycle, hopefully you took something from it. And if anyone has any questions, I would love to talk to you about it now. And thank y'all so much for taking some time out of your Wednesday to spend it with me this morning.